All right, brilliant. Well, welcome, Ulf. Ulf Barth
Hello.
is talking today on Counter-UAS against swarms, and I will say it's a real pleasure to have you on here. And thank you very much. We've had some interesting conversations in the past about deception and camouflage techniques and things like that. So I am personally really looking forward to this talk, and the same as the attendees, I assume, as well.
Okay, thank you very much.
Brilliant. So your screen will now come up and you should be able to start your presentation.
Okay. So, ladies and gentlemen, my name is Ulf Barth, and I welcome you to my presentation. Oh, let's see. Okay. Challenges in combating UAID and SUV swarms in civil and military environments. Let me say a little bit to my personal background. In addition to my civilian work as a freelancer in information technology, I have also learned a lot about security in the real world as a staff officer in the German Armed Forces Reserve. This includes stations in the tanks, reconnaissance and object protection, which in Germany means primarily the protection of its own infrastructure. I have been dealing with threats posed by SUAVs since my work for the Cyber Innovation Hub in 2017. The Cyber Innovation Hub is an institution of the German Armed Forces that promotes the work with startups and dual-use commercial off-the-shelf products. Just at the beginning, a personal statement. This presentation reflects the opinion of the author, that's me, and does not necessarily represent the position of the German Armed Forces or the Federal Republic of Germany. Due to the abundance of material, I will only briefly touch on many topics. For further questions, please do not hesitate to contact me. In principle, this presentation is based on publicly available sources. Use terms. SUAV, a small unmanned aerial vehicle, is small enough to be man-portable. The size is not exactly defined internationally and currently ranges between maybe 2 kilogram and 25 kilogram. However, these values are flexible both upwards and downwards. An UAID is short term for unmanned aerial improvised explosive device. It's a subset of a SUAV and describes a drone converted with the simplest of means for terrorist purposes. Okay. There has been, in the last 3 years, there have been a number of notable incidents, most of which have taken place in the Middle East and some of them in the Ukraine. The Islamic State in particular has distinguished itself here. The Islamic State was forced without its own air force and without sufficient resources to develop something new in the field of aerial warfare. This damage caused by the drone strike in Saudi Arabia 2019. As you see on the left picture, about 17 impacts were counted on the aerial photograph. Since there were surviving drones, the swarm will have been larger. The picture on the left shows the affected regions. The picture on the right shows the damage to individual installations. You see here, here, and in the background. Of course, it's always difficult to judge something like this from a distance. but the impacts looked planned from their distribution and seems to be very exact. So let's have a look onto the technology. That's a remote analysis of the drone, because I have not been to Saudi Arabia until now. But on the first look, that is technology for model making. That is technology I have used as a use about 30 years ago. Much of the construction was done with glass fiber reinforced plastic. That is a material that you can get very easy. It's very cheap. And yes, it seems to be, from this point of view, that the SUAV was not using any camera sensor. I think that was a GPS-guided missile or drone. I think the estimated material cost has been under $3,000 per unit. Okay, if you have a look on the right picture, it's not so good to see, but engine and propeller is commercial off the shelf. I think they were buying this thing somewhere in some kind of model shop. There's a difference between the left plane and the right plane. The right plane is, as you see, more professional. They're using painting. The forms are looking much better, and if you see on the other side, it's a very crude building, and they use a lot of duct tape to replace glue. As you see, these drones are very small, so it could easily be that this has been launched from a small ship. And it is absolutely no problem to build this in a garage. And if I would say which difficulty level, I think someone from the age of 14 to up to 99 could build this. Now let's have a look on it. The brain of the drone. It is not said that it was exactly this autopilot, but this is just an example for this. And you can, this is for a quadrocopter drone. And these components have a cost around 100 US dollar. And with this, you have a complete flight control system with autopilot, with GPS, with telemetry, radio, and in this case, with power distribution board. But there could be any kind of servo. So what the interesting thing is, you see on the see how small these things are. And the other thing is these flight control system not only works with a quadrocopter drone, but can also be easily adapted for starving drone as used during the attack in Saudi Arabia. And these components are mass products. It's absolutely no problem to buy 50 units of them in another country, put them into the hand luggage, the space would be enough, and back to home you have the control system for 50 cruise missiles with round about 1 meter precision. And that is amazing technology. And I can make this cruise missile in any garage. And that's what the quality looks like. So for this part, we start with some conclusions. The first conclusion is it's not only developed countries that can build cruise missiles with a range of more than 100 kilometers. Ambitious individuals can do so today. The United States Air Force pays about $800,000 for a BGM-109 Tomahawk. A private individual pays for a self-built cruise missile around about $3,000. Okay, less range, less payload, but the same precision. And as you can see, with soft targets, the amount of explosive is not crucial. Okay, given its size, the drone can be launched from any location. That makes it very difficult for police or for army to detect the launching site. The launch can be done from the hand with a small catapult or a cable winch, for example. That are things that are very easy to get. And the next thing is all previous concepts for airspace defense are facing major problems. You have seen this in Saudi Arabia. There's the information that at this site has been Patriot defense system, and that these systems were not able to fight against this size of a drone. And the other thing is, it is reasonable to fight. Is it reasonable to fight a $3,000 UAS with a $1 million Patriot missile? And what does the defense system do if 100 SUAV arrive? For that, you must know that a Patriot battery can actually only fight against 9 targets at the same time. Okay. Incidents involving drones are, of course, not limited to the Middle East. Such incidents also occur in Germany, fortunately, so far without any damage to persons. This example was a drone lands at the feet of German Chancellor Dr. Merkel in 2013 during an election campaign event. There's a video about it on YouTube. Back then, in my honest opinion, the bodyguards reacted completely wrong, but I'm sure they learned from this, and the next time they will handle it in another way. In 2019, there was at Frankfurt Airport had an interrupt flight operations for 1 hour, which was very expensive, only while some fool was flying some kind of drone at the fence of the airport area. But I think we heard this in previous presentations. German Air Traffic Control reports about 158 incidents involving drones only in the air traffic in 2018. So small drones are dual use, potential soft civilian targets like stadium, airports, demonstrations, or chemical plants, or a lot of other things of a technology civilization. but also military. From my point of view, this is a bad example because no one is, that's in Afghanistan, but no one is looking for any planes or drones or something. It's very open. Good. Weaponized drones. There are already existing prototypes or actually used small mini drones that can be used against soft targets. Used in the role of bomber, reconnaissance vehicle, sniper, anti-tank rocket launcher, flamethrower, or UAID. This is only a small selection, and new variations are created daily. Okay. This is a bomber drone from the Islamic State. These two drones were part of a swarm of about 15 drones that attacked the Russian airbase at Syrian Hamaymim, sorry for the watch, in January 2018. These drones were probably forced to land by electronic countermeasures. Please note the use of conventional mortar ammunition as bombs. And here's the opener. And as you see, they were using a lot of duct tape to make this drone operational. And as you see, this design was based on model planes. There are other multi-copter bombers from the Islamic State. The first picture is a drone based on a DJI Matrice 100 quadrocopter. You see there are two improvised bombs, and at the end you see very improvised the badminton tails to stabilize the flight of the small bomb. The other thing is a more self-built drone, very improvised, and you see it with a warhead. I think that is from a RPG 7. That is an anti-tank rocket, and but I think it will work too if you fly in 100 meter, in a height of 100 meter, and it fall down to the earth. That is a reconnaissance drone from the Islamic State too. They were in the construction. It seems to be more careful because it's not only for throwaway use, it's for reusing. And I think this technology is not worse than from other countries with developed military industry. That is one of drone that is built in Israel. That is the TCAT sniper drone. That is more professional, not improvised, but it shows in which direction some kind of development is going. Here the rifle is is gimbal mounted. It's a sniper rifle, and this drone is capable of stabilized shooting during flight. If you're looking on YouTube for the videos, you can see it. Here we are coming more to the improvised drones. This example shows very typically how civil technology is married to military technology. With simple means, the 250-meter range of the RPG-26, that is a small anti-tank missile from Russian production. Here you see the in the small left photo, you see the small rocket that is jute, and as you see, this drone is carrying 2 of them. And this weapon is able to penetrate 440 millimeter rolled homogeneous armor. That is technical value for the thickness of tank armor, or it is able to penetrate, which maybe you better understand, 1 meter reinforced concrete. That's all manufacturer data. And the RPG-26 was exported to many countries and is also used in asymmetric conflicts. So it's not only easy to build this in Belarus, it's easy to build this worldwide. This is another example. This is a civilian Chinese drone equipped with a flamethrower too, as you can see, clear high voltage power lines of biological waste. The problem is this technology could also be relatively easily misused or copied for terrorist purposes. Okay. Here we are having a professional product. This is a slightly larger drone from the military sector. It has a 3 kilogram warhead and can be transported at 130 kilometers per hour for about 60 kilometers. The drone has a wingspan of 120 centimeter. That is not so much. It's 93 centimeter long and 16 centimeter height. So this drone can be easily transported with a mid-size station wagon. And with such small arms, there's always the risk that these weapons fall into the wrong hands when exported. And I think as every military equipment, it's normally easy to handle. Payload. The payload of a drone is difficult to estimate and very dependent on the construction method and the mission profile. For example, the 75 kilogram heavy duty drone Griff 300 from Norway can carry up to 225 kilogram payload. That's approximately 3 times its own weight. The smaller DJI Inspire from the official data can have an official 3.5 kilogram takeoff weight and 0.8 kilogram payload. So that's about 20% of the maximum total weight. But I'm sure that there are still a lot of reserve with the risk of losing mobility. So the other thing is if you want to fly over a longer distance, you have less payload. So I think that a good reference value could be a ratio of 2 to 1. In a worst case scenario, I would assume a ratio of tare weight to payload of 1 to 2. One should never underestimate that a great deal can be achieved in this area, even with the simplest resources. So to understand what payload means, okay, even 1 kilogram payload can cause severe damage to soft targets. If it is explosive, 1,000 gram correspond to approximately 6 hand grenades. Biological warfare agents, e.g. anthrax, can be distributed over large areas by a drone. Chemical warfare agents, for example, VX lethal dose, approximate 5 microgram per kilogram live weight, that cause 1 million deaths. Theoretical. 1 million deaths per kilogram 4x, theoretical. Dirty bomb, nuclear waste plus C4. Psychological. What happens in a full stadium and a drone is distributing white powder? Maybe there's a mass panic. Or, as shown, the flamethrower is horrifying as itself. Okay, procurement of drones. The problem is, and it's really a problem, from a point of view of the security organizations, it's all available. You can get a complete drone off the rack. Commercial off the shelf. Amazon, Alibaba, a lot of other sources. You can get the flying scaffold. You can, using a 3D printer, you can build it from balsa wood, carbon fiber composite. You can get it from Amazon, Alibaba. Same to components. Flight control, you have seen Pixhawk 4 with GPS position control for 40 euro. There are some examples and proof of concepts, and that is the future, that people used smartphone as flight control. A smartphone, higher class smartphone, is normally the same sensors as the flight control for a drone. So it's not a big problem. There's some proof of concept of this. And the other thing is, in the meantime, there you can buy professional editions to the flight controller to use 5G or 4G cards. So software, drone code, for example, is open source. You can change all you want, but you can use it unchanged too and have a full system for many drone templates. Proliferation is also a problem. In the sense of proliferation in the sense of small arms to terrorists by state actors. That happens in the past and it will happen in the future too. Okay, the control of drones can be done with different methods. I've identified 5 types. The classic model aeroplane, all drones that are still controlled by humans, with or without camera. Autonomous drones controlled by GPS, e.g. like the drones in Saudi Arabia. Autonomous drones controlled by inertial navigation in case GPS fails. Drones controlled by artificial intelligence, usually by an image recognition system. All these types already exist. Also, types 4 and 5 are not yet very common. Please note that the types 3 and 5 are without active radiations, and therefore all passive radio sensors will not work. Types 4 and 5 will also be very resistant to ECM measures. Remote control range is a very interesting thing. In the past, the classic model aeroplanes were not a big threat. Only the short range of the transmitter and the fixed position of the owner on the ground made it not worth the effort. This has changed with Type 2 FPV drones, FPV for first-person view. Here the radio stations have a range of between 1 and 50 kilometers, even if this is not permitted in all countries. Game changer here is the availability of 4G or 5G networks. This makes the range of the control system virtually unlimited. A German company was able to successfully demonstrate a remote control from 8,000 kilometers. For terrorists, this means they can place the drone somewhere in the forest, leave the country, and launch the attack from a distance. Defensive measures against drones. Okay, detect, identify, tracking, fighting. Detection, radar, camera, noise detection, radio, direction finding, infrared. All the things you know. Identification, you can identify the noise signature, image recognition, frequency signature, radar signature, persecution, radar, camera, motion, image recognition, noise detection, and so on. You have different possibilities to fight against it. Counter-UAS drones, electronic countermeasures, EMP, small arms, air defense systems, passive measures, example net will I show later, laser. But not everything is suitable for use in urban environments. Please be aware of the collateral damage that happens if you use some of these measures. Okay, problems of individual defensive measures. Let us look at the defense measures in extracts, e.g. a civil airport. ECM, not real safe when aircraft or friendly UAVs are in the air. EMP eliminates any danger of drones because it's makes the electronic barbecue by burning out the electronics. But even most civilian aircrafts are not allowed to be adequately secured. Small arms, normally too short, have a too short range to protect a large area. Air defense systems, deployment against drones flying at a height of only 2 meters, that can cause major collateral damage. Normally, air defense systems are built to fight against planes that are flying maybe higher than 100 meters or 50 meters if you're fighting against helicopters. But if you're flying in 2 meters, you can be sure that your ammunition is going into the next forest, for example, and you have the next forest fire. And laser, same problem. If the laser do not hit the drone, it starts a forest fire with the laser. Or you harm any people. Of course, these are all just individual arguments. For example, the use of lasers on board of ships against drones can be useful. To determine the defense measures for a given location, all circumstances must be taken into account. But the drones can do countermeasures. Speed. Today, hobby model builders can build drones with a speed up to 750 kilometers per hour. This is about 200 meters per second or 1 kilometer in 5 seconds. And here you see it. That's really the worst case for a defense system. It's this is a remote control Type 1 aircraft with a jet turbine, which is commercial. That that model plane flies with 744 kilometers per hour. It has a weight of 7.5 kilograms and uses aviation gasoline. The jet turbine costs about 2,500 euro. That's about 2,800 US dollar. If you modified such type with a GPS module of type, so that is a type 3 drone, it could theoretically fly 200 kilometers in about 15 minutes and hits the target with an accuracy of about 10 meters. But don't be too worried. To build such a plane and to fly such a plane, you need a lot of experience that most of the people does not have. Use of the terrain. Due to their maneuvering capabilities, multicopters, drones in particular, can execute attack profiles close to the ground, and that means lower than 2 meters. There are many videos on YouTube where you can look for FPV drones and what they are doing, and you will be astonished what they can. And as a result, it's very, very difficult for the detection by radar or image recognition for a very long time during the approach phase, because it's behind a house or behind a hill or something like that. Emission control. Already today there are commercial of the Shell drones that can fly a pre-programmed GPS path as a Type 3 drone without any radio emission. No problem. Camouflage. Painted olive or painted gray or something like that. Very easy. That's maybe a problem for image recognition, but the next is really a problem. In the first photo you see a bird, or the imitation of a bird, and the other picture is the famous flying cat. And I think it would be a very interesting try to see if a artificial intelligence system that is trained to identify drones is able to identify this as a drone. Okay, noise minimization, that was in one of the other presentation tools. Yes, there are some possibilities, and I think there will be pressure on the manufacturers of drones to develop a lot of noise reducing measures, because a lot of people want to use drones in urban environment, like Amazon, like other. And the people are very unlikely with the sound of the drones. So there will be a lot of pressure to develop technologies to make it much more silent. EMP protection. EMP is one chance if you're having if you're outside of a urban area. It's maybe a possibility as a ship defense, if you're sure that there's nobody with electronic. But normal commercial off-the-shelf drones are not protected against EMP. But it's analogous to the way military equipment is already protected against EMP today. But EMP-protected drones will, in my honest opinion, primarily come from state sources through proliferation to terrorists, because for good working EMP protection, you need a good engineer or a very good engineer, and you need a very good test facility. Attack with swarms. Swarms of drones can be used to perform an overload attack against the target. I will show later something to this. But the very important thing is, it is possible that a single person is going to several electronic markets buying drones, maybe 20 or 30, is programming the GPS path, is bringing them to a roof with a timer, is going somewhere else, and then the 2 or 30 autonomous GPS drones are starting and targeting their aim. That is technical possible. The other thing is, that's more the military side from attack with swarms. The first point is the usage of the terrain is also a challenge for interception attempts, combined with the high thrust-to-weight ratio and the ability of multicopters to hover. This enables unconventional attack direction and trajectories, especially in urban terrain. So an all-round defense is required. But the most challenging factor of swarms is their number. Just an example. Most SUAVs have a top speed of 50 to 150 kilometers per hour. Assuming a detection range of 3 kilometers in typical landscape, in urban terrain, the detection range is probably much lower. The time frame for interception is between 72 and 216 seconds. Anti-air artillery systems, for example, can only fight one target per gun at a time. And so if you have, assuming the required duration of 5 seconds to detect, recognize, aim, and shoot down one target combined with the mentioned time frame, this means that a swarm of 15 or 44 SUVs, depending on the speed, range, and so on, is able to overcome the AA system with an overload attack and eliminate it with a hit. This calculation neglects potential evading maneuvers of the drones and the usage of terrain as a cover. And classical missile air defense systems such as the Patriot can only engage a limited number of SUV in parallel. Furthermore, it does not make economic sense to destroy a $3,000 drone with a $1 million missile. Okay, I see I'm a little bit late. I will go a little bit faster. Electronic countermeasure with control frequencies. Switching to control by 4G and 5G model on board by the drone. You see 4G, 5G can be disrupted, but this leads to massive collateral damage to the digital infrastructure. And it's currently impossible to identify a drone in a 4G, 5G network because you cannot see if it is a smartphone or a drone. Normally, a drone will return home if the radio connection is lost. However, the autopilot can also be programmed to take full control until the drone has reached its destination. That's something to GPS interference. That's from an Israeli startup that is able to protect against GPS spoofing. Well, it seems they have a lot of experience with this. Okay, protection of stationary installations. Just on the fly, some ideas how you can use old technology to protect a stationary installation. You can use elevated camouflage nets in the camp area, as seen on the photo that it's in Berlin at the Brandenburg Gate in 1940. You can protect it additionally with, for example, with Kevlar fabric to make a protection against explosions. There's a possibility for vertical threads with hooks in the airspace of the protected area, so that the drones have to fly very deep. You can make vertical nets in the roundup of the camp, so that deep flying drones have fly into the net or have to go up to go into the defense area. And that's used by many armies. Here's from the German army, using of smoke grenade launcher if a swarm is attacking and intrudes the camp. Then you have the possibility especially to fight against artificial intelligence drones with camera, and it makes it much more difficult to find the target. That's about active protection against small drones, some sorts. I will go over it. You can read it in the presentation then. Okay. Okay. One word to protection through geofencing. Actually, it is a good idea for commercial drones to have information about no-fly zones and to take them into account if possible. However, it does not guarantee that all protected areas are covered. From my own experience in Berlin, I know that this is not the case. And home-built drones do not have geofencing, so they do not take no-fly zones into account. So geofencing is something for the good people who possibly make mistakes, but not for the bad people who can ignore it. Okay, summary. The possibility of interfering with drones, even in the UAD area, is decreasing. It's getting more difficult. The precision of a UAD drone attack can be very high, smaller 1 meter. Terrorists are able to build precise 1 to 10 kilogram UAD with a range of 10 kilometers plus in a garage. Terrorists do not need to be on site. That makes it much easier for the terrorists. All components and software except detonators and explosives are freely available and can be obtained inconspicuously. And even terrorists can handle swarms. Outlook for the future, and with this I'm coming to the end. For the future, tried and tested concept must be reconsidered and adapted to the new circumstances. I would like to illustrate this with two selected examples from the military sector. Drones endanger armored vehicles, and swarm of drones endanger air defense. The first picture shows the almost complete loss of a battle tank in Iraq. The image is from a drone video of the Islamic State, and the drone has just manually directed an explosive device. The grenade almost fell through the open hatch of the commander and almost exploded inside the tank. It has been an AI. If this had been an AI-controlled drone, the precision would have been even higher. I'm just switching to the video. Okay. As you have seen, that was very precise. The second picture shows the weak points on every modern main battle tank, no matter which nation. The optics I have outlined in red. An artificial drone programmed for these features will in future target and destroy these points with absolute precision. This will put a main battle tank out of action for a long time because it's not so easy to exchange the optics. These capabilities do not only concern the army. Bodyguards will also have to consider them in the future. An AI drone can just as well autonomously approach the weak points of an armored civil vehicle. And as shown, a drone is much more precise as when you are firing, for example, an RPG-7 anti-tank missile to a car. The other thing is a swarm of drones endanger air defense. And here's another example from international drone research where the dual-use characters of drones can be seen quite well. China is not the only country doing research in this direction, but China seems to have realized earlier than others that swarms of SUAVs are game changers. That's the URL from the video. And that was my last page, and the video is about 3 minutes, and then we're through with the presentation. As you can see here, these are the experiments from a university in China in the year 2016 with very small drones that are acting as a swarm. And that is very advanced technology. The drones are talking together. They are not communicating with the ground station. And I think that is very impressive what the guys in China has made there. That is something that I think I think that terrorists are not able to do at the moment because they have not the time, they have not the test areas, they have not the maybe they have not the money, maybe, but I think time and time is the most important thing there. And this clip shows at the end that this is maybe in the part military project too, because they show at the end that the target of an attack with such a swarm is an air defense systems. And they made a nice animation for this. And as you see here, how this will happen. And this makes it in future very difficult to protect against this. And we must be aware that there's no proliferation of these weapons, for example, for terrorists. That's another problem too. So, any questions?
Wonderful. So thanks, Ulf. Really appreciate the talk. And there were a few questions, and I'm going to have to send you some of them because we've only got a few more minutes. So maybe we'll do one question now, and then the rest I'll be able to send to you, or you can answer in the comments and so forth.
Yes.
So the main one that I think we might have time for was someone said, you mentioned the small components that could be taken across the border in luggage, the brain of the drone.
Yeah.
Why is that? Are those components banned by export control? What's the problem?
Not at the moment, but I think there are some countries, for example, failed states, which have not a normal, what's the word for it? Normal infrastructure, so that you can't buy these components in this country. So you have to buy it maybe in another country and transport it this way. I'm not sure that, for example, Amazon is delivering in every country.
Okay, makes sense. Well, that's definitely kind of summarizes the amount of questions we have time for, because we would definitely go over. But Ulf, really appreciate the in-depth presentation. Took a few key kind of really interesting things out of that, and we appreciate your time. So thanks again. And if anyone wants to get in touch with Ulf, you can with his contact details there on the screen.
Yes, you're welcome.
Brilliant. Well, for everyone else, we're probably going to go straight into the next talk. We've got about 2 minutes to go. So we have Victor, who will come up on screen very shortly, and we'll just make sure we've got everything ready to go before we kick off the next session. So we'll do that in the background now.